Hello for you. Welcome to Miss Liang's classroom. Do you need help in math? Are you struggling with polynomial functions? Well, don't worry, because today I'm going to cover chapter 1.3, equations, graph, and symmetry of polynomial functions. So stay tuned. Okay, the topic of the day is graphs and symmetry of polynomial functions. So exciting. The goals of the day are: number one, we are able to graph a polynomial function using its equation in factor form and the order of its roots. Number two, we can identify the symmetry of a function by determining whether it is an odd, even, or neither function. So y'all gotta review grade 9 up to grade 11 first. So we're gonna start off with reviewing the concept of factoring quadratics. Yay! Okay, so we have to remember that this is the standard form of a quadratic equation. Standard form. These are the rules of factoring. Step 1. You must common factor if it's possible. This is the basic rule of factoring. Step 2. In terms of looking at the quadratic equation in standard form, if term A is 1, you have to find two numbers, then multiply to give you term C and add up to give you term B. These two numbers will become your factors. For example, if it's positive 2 and positive 3, your factors will be x plus 2 and x plus 3. Step 3. If term A is greater or less than 1, of course it cannot be equals to 0. That's an exception, because if it's 0, it makes your whole first term of your quadratic equation 0, leaving you with a linear function instead. But other than that, any number that's greater or less than 1, you must complete step 2. Then break down the middle term into two numbers from step 2. Group the terms into twos. Factor the greatest common factor from each group, and the remaining factors in the bracket should be the same. And then lastly, you take out the common factor, and the remaining is the other factor of your equation. And this is what you all call decomposition. Okay, now try it out yourself and come back to this video when you're done. Don't cheat. Okay, so now let's start off with factoring out this equation. Remember, the first rule is common factor if possible. Do you see anything you can factor out? Oh, I see something. You can factor out 2 from each of them. So 2x squared, leaving plus 2x in the bracket, and negative 15 as well. Now, what do you see? Do you notice that the first term is term A is 1, therefore you only have to find two numbers that multiply to give you negative 15 and add up to give you 2. So what are the possibilities? We have 15 and 1 and 3 and 5. Which pair is most likely to be your answer to give you 2? I don't think this is likely, so let's stick with this one because this one seems very possible. And now if it's negative 15, one of these numbers had to be negative, so let's try to put on a 5. So 3 plus negative 5 gives you negative 2, and nope, that's not what you want. So then let's erase that and try it on the negative 3. Negative 3 plus 5 equals to 2. Ta-da! That's your answer. So then now your factors are 2x minus 3x plus 5. There you go. Now let's try this one. Can you common factor anything here? Nope. But what we know how to do is decomposition. So then we could, what two numbers multiply to give you 6 times 3, which is 18, and add up to give you negative 11. So what are the possibilities? 18 and 1, 9 and 2, and 6 and 3. And you know that they have to be negative since the middle term is negative. And since 6 times 3 is positive 18, so both the numbers have to be negative. Let's try the numbers out now. Negative 18 plus negative 1 gives you negative 19. That's what you want. A negative 9 plus negative 2, oh, that gives you negative 11. So you can use these numbers to break down your middle term. So let's do this now. 6x squared minus 9x minus 2x plus 3. Now we have to group them into twos. That's our next step. And then we have to factor out the greatest common factor, which is in this case 3x, which leaves you with 2x minus 3. And since you want the other bracket that you're going to factor out to be the exact same one, in this case, I'll factor out the -1, which leaves you with the same number in the bracket. Now you could bring these down, and then it's going to be 2x minus 3. And whatever is remaining is your other factor. In this case, it's 3x minus 1. Ta-da! This is your final factored form.
If you really feel like I'm a bad teacher, then go to the website listed here. Okay, just go to the websites if you feel like you need a more in-depth review for the rules of factoring. I don't mind. It's all good.
So the second concept we're going to cover today is graphs of quadratic function. To get the factor form of f of x equals 3x squared plus 12x minus 15, we must factor. Once again, do it yourself first and come back to the videos to check when you're done. Ta-da! Here's your factor form. So this is the factored form of your equation. So we can identify some key features with this function. So what is the direction of opening? If the a value is negative, it opens downwards. If the a value is positive, it opens upwards. So in this case, it's positive 3, so it opens upwards. Now, what are the x-intercepts? Well, if you recall, if you look at the factored form, all you have to do is set y equals 0 with each of the factors. So then, for the first one, 0 equals to x plus 5, x, bring it to the other side, x equals to -5. This side, 0 equals to x minus 1, x equals to 1. These are your x-intercepts. Now, y-intercept is when you set x equals to 0. So, so let's set x to 0. F of 0 equals to 3, 0 plus 5, 0 minus 1. So that gives you 3. Solve the bracket, and this is 3 times 5 times -1, which gives you -15. Therefore, your y-int is 0, -15.
So now we're going to draw our function. So first of all, we're going to plot down our x-intercepts. So there's one at -5, 0, and there's also one at 1, 0. And we also have to consider the y-intercept, which is at 0 and -15. So with a basic knowledge of how the quadratic function looks like, if its a value is positive, we're going to draw the function. So then first it goes down, 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 it crosses the x-intercepts, then it goes down, and then it goes up, and then crosses the y-intercept, and then it goes up, and crosses the second x-intercept, and there you go. Here's our graph.
Check our understanding from chapters 1 to 2 as well. So in this case, the leading coefficient is 3 because it has the greatest power of x. So the degree of the leading coefficient in this case is 2. The sign of the leading coefficient is positive 3, so it's positive. So the end behavior of this graph, since it's an even function with a positive leading coefficient, so it's from quadrant 2 to quadrant 1. So does this graph satisfy this description? So it goes from quadrant 2 to quadrant 1. Yes. So then we can conclude that we can graph higher degree polynomial functions in a similar way. After getting all the basics down, finally we'll begin our lesson for today. So example 1 asks you to sketch this function. So the first step I'd say is to list the zeros in increasing order. So then starting from the lowest, remember the number lies in the bracket. So -4, -2, -1, 3, and 4. Next step is to draw an interval table to determine the sign of the function in the intervals between the x-intercepts. So the first step is to list the each factor on top of each column, and then you write the intervals in increasing order. So always start from -infinity to the smallest number is -4, -4, -2, -2, -1, -1, 3, 3, and 4, 4, and positive infinity. So then what you have to do next is find a number in between each interval, plug it into each factor, and see if you get a positive or negative number. In the end, you determine if the overall function between these intervals is positive or negative. So for the first one, any number that's less than -4. I would say -7. So -7 plus 4 gives you -3, which is a negative. -7 plus 2 gives you -5. -7 minus 2 gives you negative. -7 minus 4 negative. -7 plus 1 also gives you negative. So since there is negative makes a positive. Positive multiplied by a negative gives you a negative. Negative and a negative gives you positive. Positive negative gives you negative. So the overall function between this interval is negative. So next one is any number between -4 and -2. I choose -3.5. -3.5 plus 4 is a positive. -3.5 plus 2 is a negative. -3.5 minus 2 is negative. -3.5 minus 4 is negative. This is negative as well. So then there's even number of negative, so in the end the function will be positive. So pause this video and come back to me when you're done. Okay, bam, here's your interval table. Did you get the same as me? Well, hopefully. So you may ask, where does the function cross the y-axis? So y-axis meaning the y-intercept. So all you have to do is set x equals to 0. So let's do that. So it gives you 4, 2, -3, -4, and 1. So this overall gives you 96. So then therefore y int is 0.96. You can use calculator, you can use mental math if you're cool. Okay, so then now to graph this graph, the first thing you can do is locate the x-intercept. So let's do this. -4, 0. There's one at -2, 0. There's one at -1, 0. There's one at 3, 0. And there's one at 4, 0. Now let's look at our interval table. So between -infinity and -4, our function is negative. So we could draw that. Between -4 and -2, our function is positive. Between -2 and -1, our function is negative. Between -1 and positive 3, our function is positive. Between 3 and 4, our function is negative. And between 4 and positive infinity, our function is positive. So this is how our graph is supposed to look like. And now we can also plot in our y-intercept if you want to see where it locates. So it's 0.96. Ta-da! Example 2. Sketch the following function. Note that in this case, there are no 5 distinct zeros. When a factor is repeated n times, the corresponding zero has order n. So if the factor x minus 2 is repeated, the 0 x equals to 2 is identified to have order 2 because, as you can see, it's repeated twice in this equation. So example 2 asks you to sketch the following function. So the step 1 is the same. You list the zeros in increasing order. So the smallest -4, followed by -3, and then we have 2 and 5. Following the same format, we have the factors on top of each column, and then we have the intervals of the zeros listed in increasing order, and this can be easily done if you've done step 1. And then notice one thing that's different is that since x minus 2 has a power of has an exponent of 2, therefore we have x minus 2 repeated in our table. So that must be done. Okay, and then now let's complete your table. So a number between -infinity and -4. Let's say -7. So -7 plus 4 gives you -3, so it's negative. -7 minus 5 is negative. -7 minus 2 is negative. So this is all same. -7 plus 3 is also negative. We have odd number of negatives, so our overall function at this interval is negative. So a number between -3 and -4, -3.5. -3.5 plus 4 is positive. -3.5 minus 5 is negative. -3.5 minus 2 is negative. Negative same. -3.5 plus 3 is negative. We have even number of zeros, so our overall function is positive. And now pause this video and come back when you're done. Ta-da! Here's your interval table. So then now let's graph. So first step is obviously to plot the x-intercept. So we have one at -4, 0. We have one at -3, 0. We have one at 2, 0, positive 2, 0. And we have one at 5, 0. So then, looking at our interval table, negative infinity and -4, between that, we have our graph is negative. And then between the intervals of -4 and -3, our graph is positive. Between our graphs of -3 and 2 is negative. Between 2 and 5, our graph, notice that it doesn't change sign, so our graph is negative. And then from 5 to positive infinity, our graph is positive. There you go. Note that at the repeated 0, in this case it's 2, the function doesn't change signs. Therefore, if the 0 has an even order, the function doesn't cross the x-axis at that point. It only touches it. So example 3 asks you to use decimal to graph this function. Yay, technology! But then, however, I want you to still list the zeros in increasing order and draw the interval table so that you'll have a better understanding when you look at the graph on decimal as well. So this is your interval table filled out. So now I'm gonna bring in decimal for you. So as you can see, I have already typed in the equation. So now let's have a better look at the graph. So I have chosen a very ugly graph. Unfortunately, you can't really see the local extreme points. However, what you can see is that at the repeated 0, which is 2 in this case, the function does change sign. Thus, if the 0 has an odd order, the function does cross the x-axis at that point. But the higher the order of a fruit, the flatter it will appear at the x-intercept. So in this case, you can tell, this is proven here, it's really flat compared to x-intercept with an order of 1. An easy way to remember this is epoch, even turns, odd crosses at the x-axis. Example 4 asks you to determine an equation of the polynomial function for this graph. And the hint I'm giving you today is that this is the factored form of a polynomial equation. And of course, there could be more factors, and this is just the general form. So to start off, step 1 is list the zeros and determine the order of each 0. So let's follow this. Let's look at this graph. What are the zeros? There's one at -2 and one at 3. So 0 is at -2, and we'll leave a space to write the order after. So let's follow the graph to write the order. So then it starts from negative infinity. It touches the x-axis at -2. However, it does not cross it. Instead, it turns. So then it must have an even order. And as you can see, it's not as flat, so I assume it has an order 2. Order 2. And let's continue this. And then it goes and then it touches the 0 at 3, but however it doesn't turn again, so it must have an order, an even order, and it appears to be as flat as the 0 at -2. That means it has an order 2. Okay, now second step is solve for the a value, by substituting a point on the graph into the equation with the zeros. So what's the equation with the zeros? Let's see. So f of x, using this form, equals to a, the zeros now. Since the 0 is -2, it lies in the bracket. So then it becomes x plus 2. And since the order 2 is an exponent, has an exponent of 2, and the second 0 is that it's 3, so it lies in the brackets x minus 3, and has an order 2, so then it has an exponent of 2 as well. So then the point the point I see that's easier to identify is 1 and 3, and that's exactly what I'm going to use for this equation. 1 and 3. I'm going to plug 3 for f of x and 1 for x. So that's what I'm going to do. 1 plus 2 square, 1 minus 3 square. So I'm going to follow BEDMAS. So It's going to become 3 squared negative 2 squared. Then I'll apply my exponents, which gives me 9. And this gives me 4. Then I multiply, which gives me 36 and 8. And then to isolate for 8, I'm going to divide both sides by 36, which leaves me with 3 over 36, which then can also simplify to 1 over 12. Now, the third step is the easy one. So all you have to do is write the equation in factor form using its zeros and a values. So f of x equals to a value. Now you found it. And then the 0, x plus 2 squared, x minus 3 squared. And this is your equation. So moving on, we're going to talk about symmetry in polynomial functions. So here's the comparison table between even and odd functions. So first of all, in even function, the exponent of each term of the polynomial function's equation is even. For odd function, the exponent of each term of the polynomial function's equation is odd. Secondly, for even function, when you plug negative x for x, you end up with the exact same function that you started with. So f of negative x equals to f of x. For odd function, when you plug negative x for x, you end up with the exact opposite function that you started with. So f of negative x equals to negative f of x. Lastly, even function is symmetric about the y-axis, so it has a line of symmetry. And this is an example of a even functions, and you can identify a line of symmetry across the y-axis. And for odd function, it is asymmetric about the origin, so it has a point of symmetry. And you can see that there's a point of symmetry here. So use technology. Example 1. Determine if f of x is even, odd, or neither function. Then state its symmetry and verify your answer using Desmos. So let's first thing to do is plug in a negative x as x. So f of negative x. So what you get is negative 5x minus 1, negative x plus 2. Negative x minus 1. Second step, we have to simplify, so we take out the negative. So we take out the negative, it's negative 5x plus 1. Remember to put the big square bracket around it. And then second one is negative x, and what's left over is negative 2 in the bracket. And third one, we take out the negative, we get x plus 1. Now, let's see. A negative and a negative makes a positive. Positive and a negative makes a negative. So in the end, you get a negative, and your factors are same. 5x plus 1, x minus 2, and x plus 1. Now, if it was an even function, this would give you the same as this, which in this case, it's completely different. The factors and there's a negative in front. So f of negative x does not equals to f of x. Now, if it was an odd function, f of negative x will give you negative f of x. In this case, the only thing that's similar is the negative in front. However, the factors are different. As you can see, 5x plus 1, 5x minus 1, x minus 2, x plus 1, and x minus 1. So f of negative x does not equal to negative f of x. Therefore, this function is neither. Or you could say this is a neither function. This is a neither function. So the symmetry overall, since it's a neither function, there's no symmetry. And there is no symmetry whatsoever.
So now we're going to verify using Desmos. So here's a little screenshot of how the graph would look like if you plugged in an equation using Desmos. As you can see, there is no symmetry at all, so our answer was right.
Okay, so example 2 asks you to determine if the function is even, odd, or neither, then state its symmetry and verify using Desmos. Same thing, so you plug in negative x for x, so f of negative x equals to negative, oh, remember brackets every time you sub in a number, so negative x4 plus 3 negative x2. Okay, so then now, okay, let's just simplify. That's easy. So negative x to the power 4, it has an even exponent. That means that it's going to be, and it's in the bracket, so it's going to be positive x. So then positive x, but you have to multiply with outside bracket, gives you negative x to the power 4. So then in this case, same thing, the exponent is even, so then negative x is going to become positive x. So then positive x multiplied by 3 gives you 3 and then x squared. So do you notice what I notice? Okay, so this one is the same thing as this one. So what does that mean? That means f of negative x equals to f of x, which then means, therefore, this function, this is an even function. This is an even function. What does the even function have? A line of symmetry with a line of symmetry. I know that you guys all miss this iPad. You guys are in tears right now. That's why I brought him back. So now we see that I plugged in the equation, and let's see how the graph looks like over here. And as you can see, there is a line of symmetry indeed about the y-axis. So we were right.
Well, thanks for watching. Now do your homework.